I don't know also if you've seen this recent, there was this Apple paper that came out that was like quite damning. That was like the illusion of thinking. It is basically was like the reasoning models aren't actually thinking. I don't know if you have any, maybe it would actually be helpful, like if you're familiar with the paper to give a little bit of an overview of it, and then do you have any thoughts on the findings there?
Yeah, so
Super happy to be joined today by Sas. He is a PhD student at the frontier of AI today, and super excited to be hearing a lot about his insights, particularly about model and LLM eval. Do you want to do a quick introduction of yourself?
so I'm Shash. I am currently a PhD student in the Max Planck Institute and the Alice Institute in Tübingen in Germany, and I work on AI evaluations. Happy to chat about anything related to evaluations and benchmarking.
Yeah, maybe you can chat a little bit more about, how you got to where you are today and what your research is focused on in the lab.
I did my bachelor's and master's in computer science, and quite early in my bachelor's, I kind of realized that I want to do AI research, and then like I just started working on like some problems related to AI safety and how, and slowly I kind of realized that one of the key issues with machine learning evaluations is that the field moves very fast, and these days uh, like we relied on these like simple evaluations where models were quite bad, so we could have like some very simple tasks where models would fail, and for very long we were struggling there. But then suddenly we had this like exponential improvement on these benchmarks, and now we are at a stage where like it's getting quite difficult to evaluate models in terms of like how good they are finding mistakes. Like they still, we know for a fact that they still aren't everything we want them to be. We can't like just put a model and let it run for like days or something and do the whole job, but it's still hard to find what's missing. So that's what I'm trying to work on through my research.
Cool. Maybe you can talk about some of the more recent papers you guys have worked on as a team and you've contributed to.
Yeah. I guess like to start off with, there is this one paper I'm quite excited about that we put out recently, and it's also like accepted at ICML, so I'll be presenting it there. It's called "Great Models Think Alike," and this undermines AI oversight. So the motivation for this is that like, well, we have like so many companies putting out their own models, and there's in general like just so many ways to build a language model, right? Like you can change the data, you can change the architecture, how you optimize it, and so on. And the question we had was like, how different are these models really? Like in the end we get some accuracy numbers out, and if two models have the same accuracy or like the same performance, does that mean they're the same? Do they give similar predictions every time, the same outputs? And we set out to like basically measure this and see how similar model responses are. Do they make the same mistakes? Because if they make the same mistakes, then there's this risk of like correlated failures, and then it gives the user less choice. Like if one model gives you the wrong answer, then you kind of are stuck with it. You can't just go to another model and expect you will get something very different out. So yeah, so we came up with like like had some designs for like how to measure model similarity, and then we found that indeed like as models are getting better, the mistakes they make also seem to somehow get more correlated, which is a bit both surprising and maybe concerning, because that tells you that we are sort of converging to the same failures. Like for example, counting the R's in strawberry, at some point like all models failed at this task, even though it's quite simple. So and then so this was like the great models think alike part of the project, and then the second part was what are the implications for these new paradigms like LLM as a judge, where you have a model evaluating another model, and we kind of showed that if two models are more similar, then the judge would be more biased towards this model and assign it like a inflated score. So yeah, that was broadly
Yeah. That's actually a super interesting because that's actually like very counter that to what I think would happen, because I think like if you think about the way that model training has happened in the beginning, the data set was kind of the same. It was like everyone was using this common crawl off the entire internet. And obviously there was some like RLHF that was happening behind the scene, but like the foundational, maybe like initial data set and pre-training was all the same. And so why do you have any hypotheses around why, like as the models scale, they um and the models get more complicated, their mistakes actually get more correlated? Is there something like inherent within the way that we're training the models that would cause that to happen?
Yeah, that's a very interesting question, and I won't say like I fully understand why this is happening right now, but you did point out that like in the end, all the base model always starts with like pre-training on the internet. So in some sense, they are seeing the same data and learning the same knowledge. So if some things, let's say there's some misinformation in the on the internet, since models are trained in such a similar way, they would all catch on to the same piece of misinformation, maybe.
Yeah. And then I think there was, I heard this maybe maybe like, a year ago, I heard a lot more chatter around, oh, like, all the knowledge on the internet is now polluted, aka because people are now using the LLMs to generate content that's actually polluting what the content that is on the internet. And then like maybe the data quality is also degrading in some way because it's almost like it's training on itself. It's like a stack of like stacks and stacks on top of increasingly abstract things that it's created itself. Is there any evidence that that's true, or is it that's totally separate and kind of overrun now by everything that we're doing on the RL and post training side?
So this would be the case to some extent. I think you can't just expect that you would just train on model outputs and this would have like kick off some self reinforcing loop without any external source of like validation. It's almost like saying if I as a human decide just to like talk to myself for like 100 days or like 100 like 10 years, I won't really make progress, right? I need to go out in the world, interact, try some experiments and learn from what's happening around me. So in some sense, yeah, I think like with the recent RL progress, we are seeing that this grounded feedback from like ground truth rewards is very necessary to push models further.
Yep, got it. And so it does feel like there would be like a difference between maybe things that are like verifiable versus like non-verifiable, and then you'd see like an improvement in accuracy or whatever in some of the more verifiable tasks given the types of code training that we're doing today. That is more like RL based. Is that also something you guys are seeing in the data or not really?
Yeah, so I think I guess there are two parts to it. That yes, like it's definitely much easier to improve on verifiable domains because you get direct feedback there, and you can keep trying. And like for example, in code, you can just keep generating new code, running it, and seeing if it passes the test cases. Uh, at the same time, like while progress is faster on these verifiable domains, there does seem to be some evidence of like the reasoning models being better even on other domains where they were maybe not necessarily trained for. Now, this is like a bit hard to like say very confidently because I mean every domain does get some help from like better math capabilities, right? Like for example, if you are doing science, you need some like uh, if you understand probability, you would be a bit better at doing science. So there is some general transfer that one can expect, and there seems to be early evidence that we do see that.
Yeah, yeah. And so I guess given the results that there's kind of correlated failures as these models get bigger, is there anything we can do or any improvements we can make to the LLM as judge processes that we have or any kind of um, fixes to the trends that you guys are noticing, especially as the models get larger and potentially, even smarter than the ML researchers that built them?
Yeah, I think that's a very important and interesting question going forward. And so we do have like some recent work showing like one way you can fix this LM as a judge paradigm, which is that one thing we notice is that if you just give the model, like let's say the judge model has access to the ground truth answer, then uh, and like if you just ask it to match the generated response to the ground truth answer, this task models, like even small models, like if you look at the latest gen release, even like the 4B, 7B models that you can host locally, they are very good at this answer matching or like reference answer grounded grading. Uh, and there they seem to align extremely well with like, they're almost like human level at grading essentially. And in fact, they even beat like if you just ask O3 to just judge responses without having to access to a reference answer, uh, it won't do as well as like maybe even like a small local model which has access to the reference answer. So I think in general, like just giving better grounding to the judge seems like a promising direction to make the judges better as well.
I don't know also if you've seen this recent, there was this Apple paper that came out that was like quite damning. That was like the illusion of thinking. It is basically was like the reasoning models aren't actually thinking. I don't know if you have any, maybe it would actually be helpful, like if you're familiar with the paper, to give a little bit of an overview of it. And then do you have any thoughts on the findings there?
Yeah. Yeah, I think this paper definitely got a lot of attention, and they do point out something interesting under the hood. So, but maybe like I don't maybe fully like agree with the framing. So the framing was something like this. It was that they tried these tasks like puzzle games, basically. Like there's this game called Tower of Hanoi, and essentially the idea in these tasks is that the model has to perform like a very long chain of actions to be able to like solve the puzzle. And what they showed was that the thinking models, like after a certain point, or like as the number of steps gets larger, the model's accuracy starts falling, like they start making mistakes. And they call this like the illusion of thinking, and then they question whether the models can actually reason and so on. So I guess like the reason why this has been a bit controversial, and where I personally, like, let's say, disagree with this, would be the fact that, like, I mean, it's not very well defined what reasoning is, and depending on what you decide to call reasoning, you can have different interpretations of these same results. So like my personal interpretation of the results is that the model doesn't know how to solve these puzzles, right? Because it can solve it for these like smaller number of actions. It does solve the Tower of Hanoi game quite well until like it starts hitting the limits of its, like, let's say, context length or something. And the reason, like, we do have some like we have like our own like this project going on which isn't public yet, but the we do see something similar, which is that like models do like tend to like if you make them do 10,000 steps of the same action, it doesn't have to reason anymore. It has to just keep applying the same action, just be like an executor basically, which just keeps executing the same thing. And we do see that model performance dips after a certain number of actions, and the bigger models will work for more actions. And there is this very interesting like paper by this organization called METR, which showed that effective horizon lengths of the models, or like the length of the tasks that models can do, doubles every X months. So yeah, so I think there is like, with the Apple paper, there is this decoupling between what is reasoning and what is execution, just like long horizon execution. And long horizon as the execution is important, right? Like humans can do it. We want AI agents to do it as well. So it's a very important capability, and it's good to show the shortcoming. But at the same time, I won't say that the models can't think or they can't reason, because like even if they can't keep executing it perfectly for very long, they do manage to, they do know how to solve the puzzle.
Yeah, and it actually brings up a really good point, which is it possible for us to separate memorizing from reasoning, like true reasoning capability? Because I would argue that if I've seen the problem before, and this is my problem with all of the like, let's give it the Amy, or let's give it, some math problem, is most of those are on the internet somewhere. And so is it just that they have like trained to optimize for this benchmark versus, they can actually truly reason? I don't know if in your research there is a way to like disentangle the two, and then also long term, like, is there a way, do you think that the models um will be designed in a different way such that like the memory is a little bit more separated from the reasoning capabilities of the model? There's like, I would say like vector databases or like RAG are like kind of an attempt to do this, but I don't know if there's been great work that's been done maybe more on like the model sharding side, or like some fundamental architecture shift that would actually allow you to know there's a knowable knowledge base, but then maybe separate your reasoning capabilities and the approaches for reasoning.
Yeah, I think, yeah. So, I mean, first of all, yeah, I think it's a very good point that most of our evaluations, again, like until very recently, were focused on just knowledge, which is, let's say, like, so for example, just take MMLU, right? Like the idea was that they take a lot of these standardized tests across like law, engineering, humanities, STEM, etc., and then they give them to the models. Now, if you look at the data, all of this is like factual recall, where like if you know the answer, you know the answer, and if you don't know the answer, it's very hard to figure the answer out. So I won't, yeah, like you said, these are not really great benchmarks for like reasoning or like intelligence in the sense of like acquiring new knowledge efficiently. So so in terms of like what can be done here, like I think there are some interesting angles that I'm also like exploring. So one, on the evaluation side, is that people are starting to look at these live dynamic benchmarks, which is basically uh, you try to like make sure that the knowledge cutoff of the model is before when your question could have been answered even on the internet. So for example, one thing we were working on is like this task of forecasting, which is uh, essentially given like if I ask a model, let's say it only has knowledge till October 2024, and then I ask it who will win the US presidential election, uh, and like I ask it more questions like these, like, oh, like there's this sports event, who do you think who would win the Champions League or the NBA or something like that. And then the model has to kind of give like its reasoning and like a probabilistic prediction that, okay, with 70% chance I think this team would win the sports tournament. And now you want like this allows you to measure like this sort of reasoning where there could be like conflicting perspectives. The model has to balance like these different perspectives out, and then like sort of give like a probabilistic prediction of what might happen. So in some sense, like predicting the future. um, uh, and this could also happen in science, where like you ask questions from new research papers, like you see if the model can answer some of the new research that is coming out. So I think in this sense, you can maybe benchmark the model on new knowledge which it couldn't have memorized. There are some catches here, like it's in general very hard to evaluate forecasting, and this is exactly what our paper recently talks about, which is called like pitfalls in evaluating language model forecasters. And this is because like knowledge cutoffs of models are not reliable. Like they're not meant as like when OpenAI maybe says that our model has a knowledge cutoff of October 2024, they don't mean that the model did not see any post-training data after 2024. They mean that after this, the model's knowledge is less reliable or like unreliable. So you shouldn't like before this week, they give you some guarantee that it should work. After this, it may or may not work. They're not liable for that. So yeah, so I think like this is like one interesting way of evaluating models on like novel tasks. But in general, like I do think that like this is why evaluations of intelligence are so hard, right? Like this is why benchmarking is a problem. That you want to measure how good models are at this, like given a few like a completely novel task, how fast can it learn it. And creating these novel tasks is really hard. Like we do like humans can learn new things fast, but how do we get the model to do this, especially if it's been pre-trained on the entire internet? So it requires like a lot of creativity, and then you need to reason about like whether uh, your evaluation is meaningful. It shouldn't just be hard, it should actually have some real world impact, and so on.
Yep. Yeah. I'm curious in the paper about the I guess the paper was mostly focused on the pitfalls of forecasting or testing models for forecasting, but were you guys able to see that the models actually were able to forecast, and how accurate are they?
Oh yeah, so this isn't exactly from the paper, but from like again from some internal results, we do see that like models improve at forecasting. So for example, the most recent reasoning models, they are better forecasters in the sense that their probabilistic predictions are more right than the older models. So there definitely seems to be some I don't know if it's like I would call it generalization. Maybe the model developers are training for forecasting, but there does seem to be some evidence that models can do this to some extent. Obviously, it's a very challenging task. You can't get it perfectly right, which is why I'm also like excited about it, because there doesn't seem to be like some very easy ceiling that you can saturate.
Yep. Yeah. Yeah, it's super interesting from a philosophical perspective, because like maybe if the model is trained on like everything in the world up until that point, and then like it probabilistically predicts that like XYZ is gonna win the election, then like maybe that is actually like the most probabilistic outcome that the universe, like maybe like the multiverse or whatever, that we should have ended up in. But then the world is kind of chaotic, and so actually we end up in a like alternative timeline that has like a different result. I find this actually like very interesting. I think it's like not quite the right way to think about it, because post training messes up all of, it totally depends on like what you post train for and the data that it sees
Yeah.
in the post training. There's like not exactly um I take all the information and then I try to predict what's next. It's biased a little bit by all of the things that you did in post training. But I still think it's like a very interesting concept that um you could it goes back to almost like philosophically this idea of like determinism. Like if you knew, if every single butterfly wing flap or whatever, like could you predict the next thing that happens?
Yeah, that's yeah, exactly. So that's why we get like these probabilistic predictions from the model, right? Like you mentioned, like you might predict something which is very plausible and then something surprises you. So the model, like in this task, the model will always give you like, okay, with 70% probability, I think this will happen. And then you grade it based on how close it was given its probability. So yeah.
Yep.
The other thing that I would want to touch upon, which you mentioned, is like, can we like externalize this knowledge from the model, which I think is like a very interesting point, right? So I do think that like the recent search agents that we are seeing, where like the model uses search and is RL trained with search to like basically get information from the internet rather than having to know everything itself. I think this is like a very promising direction towards this, right? Where like, so if you look at like research on why we need bigger models, like one of the main things is that to store all this information that the model does need to know, like all this knowledge, you need a certain number of parameters just from a compression perspective. Like you need a certain amount of memory. And now if the model, like again, humans don't do this, right? We don't just like, we use search engines, we don't try to memorize the whole internet. And if the model can do that as well, I think it's quite interesting if like you can get smaller models to perform much better because they're not bottlenecked by their just size in terms of the knowledge they have. They can use this external knowledge source. So I think, yeah, like reinforcement learning for this does seem to be quite a promising direction where we might see more progress on.
Yep. Yeah. I'm curious, like, what else on the frontier of research you're interested in or excited about, or things that you've seen recently that you think are interesting or salient.
Oh yeah. I think there's like now with RL working and some proof of concepts of RL working, I think there's like a lot more directions that have opened up. It's become quite exciting because there's this direction of tool use where, like, again, similar to search, you can use other tools like code execution, or in the limited, like using another language model could just be a tool, right? Like you have a small model, it sometimes calls like uses API calls to a bigger model when it doesn't know things. So this like leads up to like these multi-agent setups that people have been for very long thinking about, and maybe now we start seeing practical use of them. So I think tool use is like one very interesting direction. The other thing that I am also working on and it's quite exciting is just like curiosity, where like can models like realize what they don't know, ask questions to find out like information which they are missing. Maybe like when they're interacting with the user gives some like lazy like one line query, right? But they have this whole mental model of what they want, and then can the model just ask like these follow-up questions which help it understand what the user wants, rather than just going off the rails and executing something based on its assumptions before clarifying them with the user. So I think these like, yeah, and in general, like then to like this curiosity thing can also lead to self-improvement, where models like start like seeing their own like places where they are weak, collecting data for them. And yeah, so I think in general, like just towards getting models that are better research assistants by being able to like ask novel questions or like being creative and so on. I think these are all like quite exciting directions which maybe were not very possible in our old paradigm of just training on internet data with like imitation learning or supervised fine tuning. But with RL, where you just need a reward, you don't need like a demonstration of how, like you don't need a demonstration of how research works, because that's very hard to collect, right? You need to record researchers thinking for like years to be able to collect enough data for that. But now with just like rewards on whether the research idea worked or not, maybe you can get models that can produce these novel ideas and execute on them.
Was chatting with some folks about structured outputs, which are embedded now in OpenAI. And the purpose of the structured outputs was one of the use cases is tool calling, because you don't want it to hallucinate like an imaginary tool, for example. And so if you can constrain the grammar, that can be really helpful. The problem is that if the LLM is like in a space that it's like very unfamiliar with and it has very low confidence and you're constraining the grammar, then like you're asking it to like, explore this area. It has no idea what is going on. And it just like significantly dumbs down the LLM. Um, so I think there need to also be like more and different types of training approaches that improve, tool call and reliability, but that aren't necessarily forcing the LM to explore areas that has very very low confidence in, like the constrained grammar approach that's currently being used.
Yeah, I completely agree with that in the sense that, like you mentioned, like if the model has low confidence, then ideally you want it to be able to say either I don't know or like ask some follow up questions which help it to like have a better idea of what the user is looking for. So yeah.
Is there a system or setup that can help it understand what it doesn't know, or to ask the right follow up questions? I guess that was the research of the paper.
Yes. So I think one of the things you pointed out was that like long horizon training is very hard, because if you just have these outcome rewards that the most, like for example, the DeepSeek release got everyone very excited about, is that like you can just judge whether the code was correct or not and train on this. And this gets hard as the number of steps the model takes gets longer, because now it, like if there's a 1000 step execution chain, it doesn't know where it went wrong. So any of those 1000 steps could have been wrong. And we are essentially, what we do right now in RL is we penalize every single one of those 1000 steps, even if 990 of them were correct. So I do think like this, like I think people are like in the research community and probably even internally at the labs are like looking at this idea of dense rewards, where you can reliably, in some sort of ground truth way, like give the model feedback on whether individual steps were correct. And this is also where I'm interested in like the curiosity direction, which is like if you can, like one of the papers that we have recently just shows that you can maybe measure the beliefs of the model on the correct answer, and then if its beliefs on the correct answer improve during its like multi-step process, then essentially you reward the steps that lead it towards the right beliefs and disincentivize steps that took it towards the wrong beliefs. So I think in general, like this, like a direction of tool use and then judging tool use with dense rewards, I think it can go quite far in terms of even enabling like longer horizon agents. And that's, I guess, what's going to be something to look forward to in the next few years.
Yep. Yeah. On the dense rewards point, I'm actually curious what you think about like an RL, like in production. Like you could actually have a model that's in the wild with customers, and we will do RL on it in real time. People are giving feedback on like every single step. For example, the model gets stuck at a step, like they're actually giving feedback to the model, and that's actually going back and updating the weights in real time. I guess like it's getting closer to this idea of, like when I talk to you, my weights are updating in if you think about my brain as like a neural network or whatever. And so like I'm now picking up on these things about you, and the next time I see you, like I'll remember all of these things. And the models are, it's like very sad actually, because every time you like open up Claude code, it's like it doesn't remember anything. I mean, we fudge this a little bit with the context and we just put everything into the prompt, but the fundamental weights are the same. They didn't update at all. And then like I like this concept of one line RL because it allows the model to evolve, just like it's updating its weights just like my weights are updating when I see you.
What you're referring to in how I call it is like continual learning, where like the model learns on the go as it sees new experiences and new data. So I think that's like definitely it's a long-standing problem which I think people have been trying to figure out for many years now. It started like, for example, in the image community, where even when people were training image classifiers, they wanted to like learn these distribution shifts that happen over time, where let's say like if you're trying to classify how different places look, places change over time, in like what buildings are there and so on. So I guess the big problem here is just like this problem of catastrophic forgetting, where once you update the model weights on the recent experiences, it will start forgetting some of its old knowledge. So we really don't like have this very clean way of decoupling the model's current knowledge and old knowledge. And whenever we update the weights, since we don't know what's going on in the weights, we end up updating many things we don't want to update. So I do think that there is some potential from, for example, we talked about the context things where obviously like it's difficult to like feed everything into context every time, but then maybe there's some hope that again, like maybe models can have their own like scratch pad which they keep maintaining over time. Again, you can like maybe train this even with RL, where like it kind of pulls out relevant things that it thinks it needs to remember for future conversations. So something very similar to how the memory feature in like the OpenAI models recently works. Obviously, people have like conflicting feedback on whether it's working yet or not. It's probably like an initial feature that will take some time to like polish. But yeah, I think like continual learning will definitely be like one of the important things we will need to figure out before we can totally rely on like AGI or something.
Yeah, yeah. There are some of these like memory layers that are hoping to be more like agnostic because OpenAI's memory obviously is in OpenAI, and so
Yeah.
that's fine if you believe in a future where OpenAI like owns everything and is all the applications, or like OpenAI has maybe like log in with OpenAI or whatever, and like that becomes like the unified identity platform. I think short of that, a lot of folks are thinking about how do I make like portable memory, aka I want my memory to exist even if I go to Claude or I go talk to Perplexity or I go to OpenAI, like that memory about me is actually portable or transferred in some way. So there are a couple like Mem0 is working on this, Led is working on this. There are a couple of these companies.
Yeah.
I think like the real question in my mind for all of those is like it doesn't end up being an entire company that does this. Does it end up being uh it doesn't get embedded within the frameworks themselves. So like the actual systems that are the frameworks that are managing the AI agents, like a lane chain or llama index, like does it get subsumed by those? Because I think the memory is like very important. I just don't know like what the killer use case is that gets a customer to port their memory.
Exactly. Like I guess like the challenging part is that obviously like if you are like if you want a user to themselves list down every single thing that they want models to know about them, I think that's a very clunky interface which like everyday users will just not spend that much effort maybe. And yeah, like ideally you want the models to do it themselves for you. And at that point, like uh, yeah, I could see like there are platforms which do for example, Open Router, it gets queries for like all kinds of models, right? So I could see them building this like unified memory interface which works agnostic of models. There does seem to be some thing here about like maybe some models need to remember different parts of information or like different kinds of information than others. And maybe that's a question for like how well does memory like this memory generalize across models and how you store it generalizes across models. But yeah, I think it's still like an interesting direction to think about, because I do agree that ideally users also don't want like provider lock-in where they're stuck with OpenAI forever.
Yeah, but you think it'll be like a scratch pad, like it's not going to be a fundamental shift in the architecture where it's actually like lives in the model somehow.
Oh, I think it could be that as well. I just think that like the scratchpad thing seems closer in terms of like something that it feels more tangible to me, that we will figure it out in the next months or maybe a year or two. Whereas the weight update part feels like a more challenging problem. Like I haven't like I don't work on continual learning right now, so maybe there's like very recent stuff that has made progress. But from like 2 years ago, I was looking very closely into continual learning, and back then it just seemed like very hard to constrain model weights because we just don't understand them properly, and they're all this like complex mush of like all things the model does, and it's just hard to decouple one thing from the other.
I don't know if you've seen any of the papers about like use of like sparse autoencoders. I feel like Anthropic is all over this with their Good Fire collaboration. But then I also read a paper that was like sparse autoencoders are like not even as good as prompting in some situations. I don't know if you have a thought on sparse autoencoders and that approach for mechanistic understanding.
Oh yeah, so yeah, I think like so I mean I was working in interpretability a year back, and that's when like sparse autoencoders had started to take off. I think like the general issue with interpretability is just that it's again very hard to evaluate, because you are trying to make sense of something the model is doing, uh, but you really don't have ground truths there. Like it's very difficult to know whether the model is actually doing what you think it's doing or not, because weights are complicated and like this huge like statistical mess, right? So uh, yeah, so when it comes to sparse autoencoders, I think the primary reason for excitement there is that they can find like these in the best case, if they work, they can find maybe concepts that you hadn't thought of, and even like basically get you like these unknown unknowns about the model weights, where you don't go in with any expectations and you hope that something that you understand comes out. And in that sense, I think sparse autoencoders are quite cool, like if they did work. The problem I think is just that like getting this to work turns out to be quite hard, because in the end there is like again no ground truth that you have access to, so you just hope that you train on some proxy and the sparse autoencoder doesn't reward hack, which it does. And yeah, so it's just like this complicated problem which maybe someone figures out a clean solution to, but I don't think we're there yet.
Yeah. Yeah. Okay, I have a fun one for you, which is, what is your AGI timeline? Actually, I had some people last week who were like, AGI is already here, so there's like an entire spectrum. And then what do you think actually needs to be unlocked, from an RL perspective, research perspective, whatever it might be, to get us to AGI?
Right. Okay. I think this is like so obviously like the cliche answer is like depends on how you define AGI, but then maybe I'll just like try to define it for myself, and then like maybe also like put some thoughts on why maybe people think that we already have AGI and so on. So I think what we do have is like this something which looks like artificial general knowledge, where like you can ask it any question and it can like pretty reliably retrieve like all sorts of obscure facts and also like solve some obscure problems. Basically, it's we have these models which are very general, but are like whether they're intelligent depends on how you define intelligence, right? So like for humans, like we very often like define like when we want to check whether someone is smart, we give them these like tests, and if they score highly on these tests, which are mostly knowledge tests like I mentioned, we think that they are very intelligent. And this is because I mean humans are capacity constrained, right? We have only so much time and so much memory. So to score well on those tests in these within these constraints, we do need some sort of intelligence to be able to crack these knowledge tests. Models, well, you can just train them on the whole internet, and they don't have any of these constraints because like we have such good computers now, right? We have excellent data storage mechanisms, excellent optimization mechanisms, and so on. So I don't think like these knowledge tasks, like we might have like general knowledge models, but I don't think they're like generally intelligent agents, which is what we ideally want or is like the North Star. And for this, in terms of what we need on top, I think it's like I guess we need a bunch of things. For example, like we discussed, we need like reasoning, which is just like coming up with a plan which is optimal for like the task you want to do. We are starting to see some progress here with like the O1 models, or like in general the reasoning models from all the different developers right now. So that's quite cool. But we also want stuff like tool use, where models ideally like models should be able to work with any tool that we give them, but also maybe create their own tools. And then do we have models which like suppose I got one model to design a tool, and then the next time I prompt it, like you mentioned, it would just forget that it designed this tool, right? And would it be able to like write a documentation that's so detailed that the next time it can use its own tool? I don't think we have that yet fully, right? Whereas humans can do this in some sense. Like if we today create like a new library, we know that once I put it on GitHub, like others would be able to use it and do novel things with it. So I think we're lacking this sort of like novel tool use, creativity, also like the ability to just like ask, like I mentioned, like ask questions, in the sense that like models aren't really trained on this data, right? Where like they don't know why humans ask certain questions. They don't know our internal belief states that led us to ask a particular question. So it's quite surprising, and also like maybe even intuitive once you think about it, that like models, if you look at how the deep research models ask you like these clarification questions before they shoot off for like half an hour to do their deep research, those questions are very templatic and like boring, and I don't even want to answer them. Like they don't really even get at what maybe I want to tell the model, right? So models are quite bad at this, and this is important because like, that's how research happens, right? You ask these novel questions which are interesting and which would lead to some impactful outcome. So I think many of these capabilities are still missing. Continual learning is one of them, as you mentioned, where we want the model to learn from experience, ideally collect, like realize where it's weak, collect its own data, go learn. That's what we humans can do on the internet, right? If I today know like I want to learn reasoning, I can go on YouTube, watch a few videos, and very quickly like get up to speed on what's going on in like the most recent research, or like uh, the most recent products or tools. So I feel like, yeah, this like working with new things, working for an extended long horizon period, like long horizon periods, multimodal, where like models are still quite bad at vision, all of these things I think make me make me confident we don't have AGI yet. When we will have it, I think that's very hard to predict, just because of the fact that it's not some smooth exponential that you can like maybe extrapolate, because all of these are like these discrete capabilities, right? Like when will models crack tool use? I don't know. Like maybe in 2 years we will come up with ways to train models reliably on all sorts of novel tools where they can also maybe even create their own tools. So I feel like these are like, yeah, discrete events which might happen at different points of time. There is a lot of investment, and like both like investment in terms of effort, intelligence, money, all of this going into making models more intelligent. So I think it can happen quite fast. But maybe there's like some roadblock which is just very hard to surpass. For example, like maybe continual learning is just somehow physically impossible given like some set of weights, and we get stuck there for an extended period of time. That remains to be seen.
Yeah, I mean, so I have a lot of thoughts about that, but I think like from a emergent capabilities standpoint, I think that's actually a really interesting area, which is do we have a good understanding for when or how new capabilities emerge during RL? I think that's a really interesting area of research. I'm actually curious, are there any areas of research you think are overlooked right now, aka you don't think like no one's working on it, like, or not enough people are working on it, that you think more people should be spending time on?
Yeah, I think that's a yeah, it's interesting. I think people do like eventually catch on to things that they can do given their constraints. So I think there is one part here which is that for like the most frontier capabilities, sometimes it's just hard to work on them without having access to like, let's say, the weights of like a completely frontier model, right? Like if I want open source and open weights really helps here, where like in theory now I can download like DeepSeek R1 weights and basically play with almost a frontier model. But even then, like it's like most people don't have the compute resources to like play with like fine tune DeepSeek R1 for themselves. So I do think there's like a trade off here in terms of like what is practical given the resources you have, and what is still like interesting and pushes the frontier towards like a better understanding of what models can do, what how to make them do new capabilities and so on. So in terms of like overlooked things, I do think that like again, like I mean, I am biased here, but I do think like more people should work on like evaluations beyond knowledge or towards like these other capabilities we talked about. For example, even with continual learning, I think one of the big pain points for people that work there is just that we don't have good benchmarks for evaluating continual learning. And until you can like evaluate something reliably, who knows whether the progress we are making in this, like let's say like 100 papers can come out in a year saying that they improved continual learning in models, but are they actually doing it? it it's never really clear, because in the end our benchmarks don't measure what actually continual learning is or what we want from continual learning. So I do think that in general, like evals is something that is requires more like creativity, thought, and less of compute. So you can even have like a few, like maybe a few $100s of API credits, and you can still go very, very far in terms of like designing a very good frontier eval. So yeah, that's why I work on it. And yeah, um, I guess like that's one direction that I'm very optimistic about.
Okay. Data, compute, algorithms. Those are like typically listed as like the three things required to scale AI to the next frontier. Like, what do you think is the limiting factor? And then like, has that changed over time?
I do think that like data is a huge limiting factor. This is what we saw where like we had this phase where like for 1 year or like maybe even until now, like people are still like struggling to train like let's say open models which are as good as like the frontier models from just the public internet, because there's only so many tokens out there. Once you train on all of them, what next? So this is, I think, like uh, in general, like you only like the model can only know uh, as much as the data it was trained on, and based on the experiences it saw in training. So I do think that, like personally, I think data is a big limiting factor.
Yep. Yeah. I mean, data in the beginning was a huge limiting factor for sure. And the amount that was being spent, for example, on RLHF data with scale, and you know, even Reddit was. I feel like they had like $100 million plus contracts with the Frontier Labs to sell Reddit data as training data. I guess like when I think about us moving into this new like RL post training phase, though, it feels like the types of data we need are very different because it can generate a lot of data for simulated environments. And so I'm actually curious, like, is the nature of the data that we need changing?
Oh yeah, that's for sure true, in the sense that earlier we were primarily learning from these demonstrations. So to learn how to solve a problem, you needed to see solutions written by humans for the problem. Now you don't need that anymore since RL seems to be working. And uh, so yeah, it definitely changes the type of data. We now need just more of like um, we just need more breadth in the tasks that uh, are presented to the model during training, rather than like human demonstrations of how to solve those tasks. So that's definitely a big qualitative shift. um, when it comes to like just
And wait,
how.
sorry. So just to dig in a little bit on that, so for the RL, like the types of data you would need are here's a task and then here's the end result, or I guess yeah, maybe you can drill into a little bit more like what is the actual type of data.
Yes, exactly. So now for RL, it's yeah, like more towards here's a task, here's an evaluation, which if you get high scores on this evaluation, then you're definitely doing something right. And this is the hard part, because like when you set up the evaluation, the the first problem that people run into is reward hacking, where because your
Yep.
evaluation is not exactly what you want to measure, the model will start like finding these shortcuts to like increase its score on the evaluation without actually maybe learning the task that it was supposed to learn. So I do think, yeah, like in now the data that we need is shifting more towards like setting up these environments where you have like a very tight reward signal, which is exactly what you want the model to optimize.
Yeah, that is like an interesting though, because like you know the entire like scale AI's entire business was like is all these human annotators, and you know they were doing increasingly more sophisticated things, so they had acquired also a ton of PhDs, and then the PhDs were, you know, writing very esoteric, I guess, legal documents or providing corrections on legal documents or coding samples. So are those humans no longer needed, or are they, I guess, they're generating tasks and evaluation criteria?
Uh, yeah, so I'm not sure I would say that they're no longer needed, in the sense that there are these like domains where we don't have verifiable reward signals, like code execution, where like if in the end, like if you think about it, if you want models to do creative writing and become better at creative writing, the end goal is just something that humans like more, right? And the only way to measure that is giving it to humans and seeing what they like more. uh, but I do think that one thing that is maybe changing is, for example, for uh, like long horizon actions. The reason maybe why models are bad at long horizon actions is that it's very hard to collect long horizon action data from humans, right? You just need the like even like in terms of just like the cost per sample. If you want the human to annotate how they did something for like a month, you would have to pay them a month's salary. So this is very hard to scale up. Like you would have to hire like if you need 1 million data points, you need to pay for like 1 million months of human labor to collect like a million month long action sequences. So yeah, this I do think that this starts running into some issues with whether this can be scaled in this way or not, and maybe this is not the most efficient way to collect data then. What is interesting is that for example, with computer use, you can define these environments where we have this sort of like a generator verifier gap where uh, the model, let's say, the task is like to create a website with a certain specification. The model works on creating this website for a few hours. You have this inference time compute. And in the end, for a human to grade whether this website is exactly what the spec wanted, maybe they just need a few minutes and they can see if there's some bug in the website in a few minutes. So there is this like generator verifier gap here where generation is much harder than verification. And now you can have like humans verify for the task and train the model with RL to become a better generator for the task. So I do think there's like some innovation happening in how we set up these environments, which is very important. Like what tasks can we just scale supervision on in a way which is automatic, requires less human effort, and it reliably keeps improving the model as the model optimizes this training objective.
Yep. Yeah. It's especially with the Scale AI acquisition recently by Meta, like there's a part of me that's like, there's some dystopian future where like the humans are just, we're just like data collection or like, yeah, we're verifiers for, do the humans like this website or whatever. And we're just in these training loops. And then everyone's job in the future is like some mechanical Turk type of job where we're just in these verifier loops to train the LLMs. That's like a very, very dystopian future. Or like maybe like, we haven't on the robotic side and like humanoid robotics specifically, like we haven't cracked the code from like getting from videos to like motion policies, but like maybe some, I've seen some research papers that seem like somewhat promising on like translating those things. And so maybe eventually also it's like we get humans to go, open a can or something and then just like do that repeatedly, and you get tons and tons of samples, and then we use those videos as training data in some capacity down the road for a humanoid robot or whatever. So that's like one very dystopian world where the humans are just like almost like appendages in the real world for training the LLMs.
Yeah, that's I agree that it's quite dystopian if humans are just like annotating data. There is like a more optimistic perspective to this maybe, which is that if you think about it, like what, let's say, a manager does or like a CEO does is like it just tells these human agents to go do something which they want, and in the end they just assign evaluations for, oh, like this looks promising, this doesn't look promising, this is how you could do it better, and so on. And maybe like everyone ends up being like their own controller of like these AI agents, which seems promising, where you don't have to do like maybe the mechanical painstaking work, and essentially you can translate your ideas into like reality very fast by working with these AI agents. So that's the more optimistic picture. But I do agree that like, yeah, if like robotics progress is, for example, slow, then I mean there's only so many people that can be like managers or CEOs, right? And then what happens to the others? And I do feel that's a potentially scary future.
Yeah, you painted a much happier picture. I do hope that ends up being the world that we live in, aka I actually think there's a potential world where it's like people have, whatever, there are 10 times as many businesses as people, and then the people are just able to orchestrate, armies of AI agents. So that would be, and robots, I guess, long term, but that would be a very lovely future. And then people hopefully are able to do less work and we can frolic in meadows and happy things.
Yeah, I guess the question is just like how much demand is there for businesses, right? Like let's say we have infinite supply of the businesses we can create. Do people need all these things? We'll find out.
I mean, I think humans will always seek experiences, so maybe it will be toward orchestrating experiences.
Yeah.
Cool. Well, thank you so much.
No, I think this was quite nice. It was nice to talk about these things that I've been thinking about for quite some time now.
One thing that struck me as we were talking is like talking to you feels like talking to like Darwin, when he went to the Galapagos Island and he was like, there's a new species of like bird or whatever. I'm trying to like understand how the bird works, which I think is so interesting because it's almost like it's a new species that we created, but we're like still trying to figure out how it works, like how it what is actually going on under the hood, because it can generate things that seem very probable, but how is it actually understanding the world, is actually reasoning. It feels like almost like analyzing a new like species. It's very cool to talk with you, and it's been just delightful and an absolute pleasure. How do people find you? And then it sounds like you'll also be at ICML this year. Is there a preview you can give us of what you're going to be presenting there?
Oh yeah. First of all, I mean, thank you for that like very optimistic picture of me. But I mean, I do agree with you that like being an evaluations researcher essentially means like trying to figure out like what models can do, what is fundamentally hard, how can we improve it, and so on. Like new tasks, new environments where we can improve these models, and so on. So when it comes to like yeah, I will be at ICML. I'm always like open to DMs on X, emails, and so on. And yeah, at ICML, I'll be presenting like some of the work that we talked about actually. Like in the beginning, we talked about the model similarity paper where we showed that great models think alike. And then I will also be presenting some of the forecasting evaluations work, the beliefs, curiosity work. So it just so turns out that like a lot of the work that I've done in the last 8 months of my PhD, all of that ended up getting accepted at ICML either to the workshop or the main conference. So essentially, I'll be presenting everything I've been thinking about for the last 8 months at ICML, which is very exciting because I get to talk about all these things in one place.
Amazing, cool. Well, I mean, your passion definitely shines through. So we'll see you there at ICML, and thank you again so much for joining us. This was such a pleasure.
Yeah, thank you. Thank you so much for this interesting conversation.